No attendance today. Could have skipped, win the count against you, but you're here now, I got you, so. Bonus point? No. That'd take me more time than taking attendance to give you bonus points.
Yeah. I need to say.
Yeah, email me. That takes time. Time I don't have. All right, so a couple things. Remember next Tuesday, which is the 31st, is that right? 31st is our first exam. It'll be on chapters 8 and 9, so we're going to spend today getting ready for that. First, we're going to go over the homework. As well, on Thursday, February 2nd, Groundhog Day, we will have a little in-class Excel thing, and we also have an Excel assignment that will be due to Thursday. So next week is assessment week, if you will, right? So it's a big week. So what are we talking about? Let's go there first. We're talking about estimation, and we've learned what a powerful tool estimation is. It allows us to take a sample statistic and make an inference about a population parameter. Once where we had no information, now we have some confidence level that the population parameter we're interested in is in a certain range. That range we call the confidence interval. It has a low and a high, the LCL and the UCL. So we estimated means using sample means, population means using sample means. Last class we started estimating population proportions, P, using sample proportions, p hats. And the formula we've been using looks like this. P hat plus or minus z sub alpha divided by 2 times the square root of p hat times 1 minus p hat divided by n. So I asked you to do a couple manually, meaning by hand, and I asked you to do a couple with Excel. So I'd like to do one of each of those today just to kind of put a lid on that section. So I think the two I assigned you manually was number 4 and number 5. Is that correct on page 145? So choose one. Would you like to do number 4 or would you like to do number 5? 5. I'm hearing 5. Okay, so let's look at number 5. So we have no clue what kind of educational backgrounds CEOs have. So we're going to try to estimate the proportion that have MBAs, right? We think MBA is a credential that maybe allows you to get into the C-suite, the CEO's office. So it says, in what type of education background? In one survey, 344 CEOs of medium and large companies were asked whether they had an MBA. 97 did. Estimate with 95% confidence the proportion of all medium and large companies who have MBAs. Okay, so if we, and obviously, as always, you'll be given the formula p hat plus or minus z sub alpha divided by 2 times the square root of p hat 1 minus p hat divided by n. So if we look, give me something you recognize, give me one thing we're going to parse out of that word problem. What do we know that can go in that formula right now? We know what? Okay, 95% is my confidence level. And we know that that relates directly to z sub alpha divided by 2. And we know that that is now 1.96. Okay, and I'll give you that table so that you can look that up if necessary in the table, right? So nothing you need to memorize there. What else do we know in that word problem? What else can we find in that word problem? Very good. The number I sample is n, and we know the more we sample, the tighter our confidence interval gets. So n is equal to 344. So I know z sub alpha divided by 2. I know my n. All I really need is my p hat. P hat is a sample proportion. We sampled 344, and 97 said they had an MBA. So 97 out of 344 would be my p hat. So let's get that value. So I'm going to go 97. I don't know if you guys can see this or care to see it. 97 divided by 344 gives me 28 point, we'll call that 28.2%, 0.282. So you guys see where everything came from? So it's a matter of plugging and chugging now. So let's do that. We're going to do 28.2 plus or minus 1.96 times the square root of 28.2 1 minus 28.2 divided by 344. Okay. So a lot of calculator work here. We're going to do 0.282 times, and I'm going to do 1 minus 0.282. And that's the numerator, that's this times this. Divide by 344. And then we need to take the root symbol of that. And then we need to multiply that by 1.96. And we get 28.2% plus minus, let's call it 4.8%. Okay? You guys get that? Yes? So how would I get the LCL? I would do what? LCL, I would subtract. The UCL, I would add. So if we subtract, that looks like it's, on these pens work. So 28.2. Looks like I get 0.234 as my low. And I get 0.330 as my high. How confident am I that the true average is in that range, 23.4% to 33%? I'm 95% confident. If I know, and it didn't ask you this, but if I know there are 100,000 CEOs in the United States, and I want to estimate the number that have an MBA, how would I get there? The number that have an MBA. That's the percentage that have an MBA. How would I estimate the number that have an MBA? I would do what, Brandon? Very good. I'd multiply the top and the bottom by 100,000, whatever the population is, which is 100,000 in my example. And I get there's roughly between 23,400 and 333,000 MBAs in the United States, CO MBAs in the United States, right? So now I know that demographic. Good. Any questions on that? You guys are able to do that? So that's, that's going to be a problem. There's going to be a problem like that on your exam. So that should be pretty easy, right? Just working on your calculator, no issues there. All right, so then let's do one with Excel. I think I assigned you 14, 15, and maybe 16? Or was it 13, 14, 15? I can't remember. 13, 14, 15. So which of those would you like to do? Is there one in particular you'd like to do? It's your show. What do you think? Tommy, what do you want to do? Which one? Pick a number, Tommy.
We'll do 15.
All right, we'll do 15. So let's see. 15 says, a California university is investigating its evening programs. It wants to target people between 25 and 54 years old who have completed high school but did not complete college or university. To help determine the extent and type of offerings, the university needs to know the size of its target market. A survey of 320 Californians, adults, was drawn, and each person was asked to identify his or her highest educational attainment. The responses are: 1 did not complete high school, 2 did, 3 some college or university, 4 graduate. The statistical abstract of the United States indicates that there are 15 million people in California in that age. So that's published data, right? So that's, I don't have to gather that. In the United States, my tax dollars pay for that. Estimate with 95% confidence the number of Californians between 25 and 54 years of age who are in the market segment the university wishes to target. So who am I targeting, I guess? Who would I target in this? We have 1s, 2s, 3s, and 4s. Who am I interested in targeting? I want to see how big my market is. Who would be available for my program? Who would I be interested in targeting? 1s, 2s, 3s, and 4s. Which ones make sense for me to look? Okay. The 4s already have a degree, right? So they're out. They're not interested in my undergraduate degree. They already have a degree, most likely. I mean, you can get 2 undergraduate degrees, but 4, they don't care. Tommy?
Is it 2s and 3s?
I would say 2s and 3s. Like the 1s, they need their GED, right? They don't even have a high school diploma, so they're not our target market. But 2s, they don't have any undergraduate degree, so they might be interested. And the 3s, you know, they have some college or university, but not the whole way, so maybe they're interested in doing like a degree completion deal with us. Does that make sense? So we want to see the size of that market. So let's go to Excel and fire up the data. This is number 15. So I'm going to go to Blackboard, and I'm going to go to Book Excel Files. Book Excel Files. This is Chapter 9. This is number 15, XR09-15. And here's my data. So we have education. I think that's the one we're interested in. I don't know what course is. Looks like they're all 1s anyways. But education is what we're interested in this data set. So give me a way that I want to figure out a percentage of the 2s and 3s out of the total, because if you recall, I have an estimator workbook, Chapter 9, Introduction Estimation, Estimator's Workbook Template. I have a tab that estimates proportions for me, and I have to give it 3 things. I have to give it what? I have to give it a sample proportion, a sample size, and a confidence level, and it wants 95% confidence, I believe. So we use 95% confidence. Okay. So how would I do that? How would I do that? Come on, there's a couple ways I could do it. Give me one way I could do that. All right, I can count the number 2s and 3s, but I'm going to use a tool. I'm going to highlight column A. I'm going to go to Insert, Pivot Table, click OK. I'm going to drag education to the rows. I'm going to drag education to the values. Now I know I have 125, looks like 170 out of the 3. I thought they said 344 we sampled. No, 320, okay. So we have 170 out of the 320 that are 2s or 3s, okay? So how can I get a percentage? What could I do to get a percentage? A couple things I could do. What could I do? Okay, so I can go grab this under there, change the field settings, and I can say, yeah, change it to percentage of grand total. But I want the 2s and 3s together, right? I don't just want 2s. I could estimate just the 2s. I could estimate the 3s. But I want to include both of those responses in my estimate for a market. So what I would do is I would add those two. So that is what? C6 plus C7. So it looks like I have 53.13%. You guys with me? So I need to take that information, 320, 53.13%, and I need to go to my estimator workbook. I'm just going to copy that over. Copied it over as the formula, so I'm just going to enter it. 0.5313. I sampled 320. It asks for 95% confidence interval. Boom. And it's telling me I'm estimating that 53% plus or minus 5% are in this target market of California, right? In that 25 to 54 age group, about half would be available for my product. But what I'm real concerned with is how many, right? Because I want to know how big that market is, not the percentage of people that qualify for my market, but how big. What value in this original problem do I have to use to figure out the bigness of my market, the size of my market? What value do I have to use? Yes? Why aren't you guys talking to me? Let's know. Mad at me? My wife doesn't talk to me, I know. What's going on? I need the 15 million, right? That's the whole population. I want a subset of that population. So what I'm going to do is I'm going to come over here and I'm just going to enter that as, I don't know, I'll just enter that as a, the Cali population. And what is it? 15,753,123. Might as well make that comma so it looks nicer. So that's the California population. Get rid of the decimal points. Now I want the lower and upper level, so I'm going to say take E5 and multiply that by B8, that Cali pop. And I'm going to make that absolute because I'm going to drag that down. Remember, the F4 makes it absolute. I hit enter, drag that down, get rid of the decimal places. And I'm estimating the size of my market for this new program I'm about to come out with, somewhere between 7.5 million and 9.2 million. And this makes, estimating the size of a market is a great business use of estimating a proportion, right? If you want to put out a new product, typically you don't have the funding to do it yourself. You want to start a new business, you have to go to the bank or investors. And investors are going to want to know, well, how big is the target market for this product or service? If you're opening a restaurant, they'll want to know, right? They want information. They want information, and you can provide that. You say, well, you know what? I've done an estimate. I know there's this many people in the metropolitan area that I'm looking at. I know there's this many 20 to 30-year-olds. This is the percentage of them that I estimate would be interested in my product. I multiply that out. I have a size of my target market. Jonathan?
Do you need the F4 before or after you multiply?
The F4 is, let's go to control tilde. So you remember, that we're going to do E5 times B8, right? B8 is the population, the percentage times the population. But I knew down here I was going to do E6 times B8.
Right.
And I could have just typed it in, but I know that I'm going to use this formula, the same thing, but I always want to multiply by B8. So I highlight B8, remember that? And I hit F4, and it puts the dollar signs around it, makes it static. Okay?
You didn't have to do that.
I didn't have to. I could have typed in, E5 times B8. I could have typed in E6 times B8. Okay. But, I want to do my things most efficiently in my life, right? Like,
Did you record today?
do I have a what?
Did you record?
Yeah, I'm recording, yeah. All right, any questions on that? Mr. Boyd? When you go back to the pivot table, yeah, so I could have just left with the count, and I could have added 125 and 45 and got 170 and do 170 divided by 320. But once again, make Excel do the work for me. So what we did, Mr. Boyd, is we took that count of education and we drug it down here again, right? But remember, it just gave us the count again, but I clicked on the drop down, I went to value field settings, and under show value as, I said shows a percentage of the grand total. So it's going to take that 125 divided by 320, that 45 divided by 320, make it do the math for me. Does that make sense? Okay, so let's talk. Any questions on the homework then? All right, then your exam. Let's talk about the material for your exam. Your exam, might as well go to the book here, that's probably the best. Your exam will be on chapters 8 and chapters 9. Okay, chapter 8, if you recall, was sampling distributions. And remember, we started with, way back in week 1 of this course, we started with the die example. Do you guys remember that? And we derived what is the most important theorem in inferential statistics. What was that theorem? Do you remember? the central limit theorem. So that was in section 8.1, sampling distribution of the mean. And the formula that we used, I don't see it here, but the formula that we used, I might as well write it, is when we want to convert x bars to z's, we use this formula. And you'll be given that formula. You guys remember that? Okay. We also talked, and it'll be one problem on that. We also talked about the sampling distribution of a proportion. You guys remember that? So sampling distribution of a proportion, the same thing. And we used a formula for that. We said z is equal to p hat, where p is the sample proportion, minus p, divided by the square root of p times 1 minus p divided by n. Holy moly. I gotta get a good pen. So 1 minus p divided by n. These all junk. So you guys, there'll be two problems from chapter 8. Does that make sense? One, we're doing the sampling distribution of the mean. One, sampling distribution of the proportion. Does anyone have a pen I can borrow? These are all, I'm using like the school business giveaways and they're all dried out. You guys want some free pens? Thank you. Well, this is a school business giveaway. These are like the new school one though. So z is equal to p times 1, this is nice, divided by n. Okay, so that's the second formula.
I'll just steal another one.
All right, the second section, so that first section, central limit theorem, real important. There's going to be multiple choice. I'll show you what that's like in there. The second section that we covered, second chapter, was chapter 9, Introduction Estimation. And we only did sections 1 and 2, which is concepts of estimation. So that's all the terminology we talked about, like confidence level, LCL, UCL, confidence interval, all those good things, biasness, unbiasedness, consistency. A lot of the vocab over here you see, that's all relative. That'll all be in the multiple choice. We also did, and that, remember that material was on the PDF. When we estimated the population mean, that was in the PDF. And the formula we ended up using for estimating the population mean was this. So there'll be one problem where we have to use that formula. And what we just did was estimate the population proportion. And we used, that's a funky Z, we used this formula. So 4 problems, okay? You'll do all 4. 2 on sampling distributions, 2 on estimations. We did not do section 3 in chapter 9. I don't know, we probably will never do that. So you can ignore that, okay? All right, so what I have prepared for you, so we can review this, is I'm passing out a sample exam. It is also available on Blackboard under sample exams. You guys take a few moments, we'll go over this and then we'll do it together. Take like 5 minutes, I guess. Knock out as much as you can. I'm going to pause the recording, so remind me to start it again. So the multiple choice will consist of a lot of those terms, concepts of estimation, the central limit theorem, all those good things. So let's look at these. These are, I think I only have a sampling of multiple choice. I didn't make the exam yet, but I guess 20 to 25 multiple choice. I don't know yet. I'll have to make the exam. The term 1 minus alpha refers to what? What would this be? This is a vocab terminology. Very good. This is the level of confidence. So letter B would be the correct answer. Which of the following is not a characteristic for a good estimator? Consistency, relatively efficient, unbiased, biased. Yeah, obviously you don't want something that is biased, right? You want an unbiased estimator. So A is the correct answer. This is real important, like understanding the confidence interval and when it narrows and when it widens. That's an important concept. We talked about that. So a 98% confidence interval for a population mean is determined to be blah, blah, blah. If we reduce the confidence level, what happens to the confidence interval? So if we say we can be less confident, what happens to the confidence interval? It becomes narrower. Remember, confidence level and confidence interval move the same direction, right? So if I reduce it, it's going to become narrower. I can give you a tighter range, but I'm less confident. If you need me to be more confident, I need to give it a wider range. How about n? We increase n, what happens to the confidence interval? It goes down. So sample size moves opposite direction. Confidence level moves same direction. Does this make sense? There'll probably be 2 or 3 multiple choice like that. So get that concept, you got 6 points. Nice. An estimator is said to be consistent if what? Anyone know? This is vocab. D. You are right. Yeah, you probably won't even know that. You could just tell, right?
Right. I mean, you wouldn't write all that.
Yeah. As its name suggests, the objective of estimation is determine the approximate value of what? Generally speaking. What do you think? Estimation, thank you, Mariel. A, we're trying to understand or estimate a population parameter, whether it be mu or p, based on a sample statistic, whether it be x bar or p hat, right? So we're using a sample statistic to estimate a population parameter. That's what we're doing. So all these things are estimating samples. No, we don't estimate samples. We calculate out samples and use them to estimate parameters. Number 7, the larger the level of confidence used in constructing a confidence interval, the what? So if the confidence level goes up, the confidence interval also goes up or widens. C. According to the CLT, which is short for central limit theorem, the mean of a sampling distribution is blank the mean of the original distribution. It is the same as. Very good. That's the first thing. First thing that's part of the CLT says the mean of the sampling distribution is equal to the original mean, right? The standard deviation or the variance, remember, the variance of the sampling distribution is equal to the original variance divided by n. Or the standard deviation is equal to the standard deviation divided by the square root of n. Third thing that we might want to know for the multiple choice is what shape does it take on when I sample enough? The sampling distribution always takes on what shape? Bell-shaped, also known as normally shaped. So normal, those are the 3 things. I only have 1 here, but I'm guaranteeing you I have 3 or so on the actual one, asking about attributes of that theorem. What if I said this? What if I said I estimated the population mean and I get a confidence interval of 50 is the LCL and 60 is the UCL? And I ask you the question, what was X bar? Think. What was X bar? So my LCL is 50, my UCL is 60. What was X bar? Very good. Who said 55? Thank you, Lauren. Right, because the point estimate is always in the middle, right? So it was 55 plus or minus 5, right? That would have been, it's always in the middle. Does that make sense? It's the middle, and we offset it right, we offset it left. Yes? Yes. What other questions might you have about like the multiple choice or the concepts that'll be on the multiple choice? Yes, sir.
Okay, for the second formula there, that you divide it over the root of n, right?
Yeah, so that's a good question. So if I tell you the original, I don't know, the original standard deviation is, let's make it easy, 50. Okay, that's the original standard deviation, okay? And I say I sample 100. Oh, that's not. And I sample 100. What's the standard deviation of the sampling distribution? If I sample 100, is it going up or down? What happens? The more we sample, what happens? The narrower it gets. So if the original standard deviation is 50, and I sample 100, what's going to be the standard deviation of the sampling distribution? 50 divided by the square root of 100. The square root of 100 is 10. 50 divided by 10 is 5. That'd be a good multiple choice. I'll put that on there. That's a nice one.
I just feel like, I thought in one formula we multiply by the root of n in the denominator of like an equation, or is that not right?
Nope.
We always divide, right?
Always.
Okay.
N is always in the denominator because, well, I mean mathematically, but because the bigger the n, the smaller the confidence interval, right? So it's always, we never multiply by n. It's always in the denominator. Okay, so let's look at the problems. And I'll also give you a few minutes. Did you guys get to the problems yet? No? So let's just look at these and you tell me what we're doing in each of them. Sometimes students struggle with that. Like what, you see a problem and you're like, I don't know what to use. So let's look at the first one. A random sample of 10 waitresses in Altoona revealed the following hourly earnings, including tips. If the population hourly earnings are normally distributed with a standard deviation of 4, estimate with 95% confidence the mean hourly earnings for all waitresses in Altoona. What is the LCL and the UCL? So what am I doing here? I'm estimating what? It's an estimate because you see LCL and UCL. What am I estimating?
Average wage.
Yeah, and that's the population mean, right? Estimate the population mean is x bar plus or minus z sub alpha divided by 2 times the population standard deviation divided by the square root of n. That's the formula you want to use. So I'll give you the formula, but you need to know when to apply it. Let's look at number 2. It says the amount of time spent by North American adults watching TV per day is normally distributed with a mean of 6 hours and a standard deviation of 1.5 hours. What is the probability that a randomly selected North American adult watches more than 7 hours? So if we're talking about an adult, is that an X or an X bar? That's X, right? So we would use this formula to convert the X to a Z value. But here, we're talking about sampling 9 and averaging together. And here we're talking about sampling 100 and averaging together. We talking about X's or X bars there now? X bars. So I'm going to use this formula to convert X bars to Z values. That's the sampling distribution of a mean. That was like the section 8.1 of our text. Okay. Let's look at number 3. The marketing researcher is trying to ascertain the size of a market for a new luxury car to be sold in the country of Mikovania, an island nation with a population of 4 million. The car will be marketed toward residents of Mikovania that make more than $100,000 per year. To assess the size of the market, a survey of 987 Mikovania residents is taken and has found that 117 of these residents make more than $100,000 per year. With 90% confidence, estimate the proportion of all Mikovania residents that make more than $100,000 a year. I'm estimating what? It kind of says it. I'm estimating a proportion p hat plus or minus z sub alpha divided by 2 times the square root of p hat, 1 minus p hat divided by n, the thing we just got done doing. That was section 9.2, I believe. And number 4, CEO Miko tells you that the market share for his Miko widget in the widget market category is 70%. You take a sample of 200 people that use widgets. What is the probability that less than 135 use Miko widgets in the sample you take? So this is the sampling distribution of a proportion, where this was like section 2, I believe, in chapter 8, where we convert p hats to z's using this formula. Our p in this case is what? What is p? What do I believe about the population? It is, what did I tell you is my market share? 70%, that's p. Where's p hat? N is obviously 200. Where is p hat going to come from? 135 out of 200 and 100 out of 200. So those are the 4 types of problems, right? Those are the 4 formulas you need. You need to identify when to use those formulas, you know, but those are the 4 types of problems. The math isn't really that hard for any of them, actually. You know, hopefully you're able to do it. You just want to do them together now, or do you want a little time? Vote. Now? 1. Later? 0 or 1. Time. So, and we have 28 abstentions. Apathy. Mr. Boyd, what do you want to do? Leave? Oh, we're not leaving. Yeah, we're not leaving. Cripe. I mean, you can leave now. It's a free country. Leave if you want. You know, I'm not going to hold it against you. Leave. But we're going to go over the problems, which is what you're paying me to do. If you don't want to consume that, I don't care. You know. All right. A random sample of 10 waitresses in Altoona revealed that the hourly earnings, including tips, are this. If the population hourly earnings are normally distributed with a standard deviation of $4. Estimate with 95% confidence the mean hourly earnings of all waitresses in Altoona. We're going to use this formula. We already talked about that. So let's see. What do we know in this formula? You guys help me. What do we know in this formula that we can just write down? No big deal. What do we know in this formula? N is 10. Thank you, Mariel. So N is 10. What else do we know? Standard deviation is $4. Good. What else do we know? Confidence level is 95%, which means Z sub alpha divided by 2 is 1.96. Great. All I need now is X bar. What is X bar? Add those up and do what? Okay, I'm going to add all those up and divide by 10. So, did someone do that for me? So, 171, if we add all those together, divided by how many there are, there's 10. It comes up to 17.1. Is that what you guys got? All right. So now it's just a matter of going through the math. 17.1 plus minus 1.96, 4 divided by the square root of 10. Let's do 4 divided by 10 square rooted. Gives me 1.26 times 1.96. Gives me $17.10 plus or minus $2.48. It asks for the LCL and the UCL. The LCL then would be, let's see, $17.10 minus $2.48, or $14.62. Add it, and I get $19.58. So I am 95% confident that the average hourly earnings of Waitressing in Altoona is somewhere between $14.62 and $19.58. Yes, that's easy. That's number one. And I'll put these on Blackboard as well. Good? Number two might have the most work. I don't know, maybe, yeah, 2 probably has the most work. The amount of time spent by North American adults watching TV per day is normally shown with a mean of 6 hours and a standard deviation of 1.5. So let's draw our original distribution. So mean is 6 hours, standard deviation is 1.5. The very first one says, what is the probability that A, randomly selected North American adult, watches more than 7? So what is the probability that 1 watches more than 7? What do I need to find? I need to find area under the curve greater than 7. Do you guys remember this? So I'm going to convert X to a Z using this formula. Probability that Z is greater than X minus mean divided by standard deviation. Mean, standard deviation, gives me the probability that Z is greater than 0.67. So we have to use, remember I told you we'll use this a lot. We have to use, and I will give you a Z table, you can bring your own. We have to use our Z table. I look up 0.67. I get 0.7486. But because it's greater than, what do I have to do? 1 minus 0.7486, which gives me there's a 25.14% chance that we get that 1 and he or she watches more than 7. You got that, Stefan?
You slow down like a little bit.
Yeah. What? I'm sorry, Stefan?
The 2 greater than 6.
Z is greater than, for the first one, we're converting an X to a Z value, and we're going to use that formula. Okay? X is 7, the mean is 6, standard deviation is 1.5. Now the next two, I need to convert X bars to Z values. Remember, the central limit theorem says this is the formula I use to convert X bars to Z's. So part B says, hey, we sampled 9. What's the odds? You guys can't see this. What's the odds that that average is greater than 7? If we sample 9, the average is greater than 7. Well, before we do that, just visually what happens? If I sample more, what does the central limit theorem tell me? The mean stays the same, right? And what happens? Does it become narrower and more peaked or more spread out? So just visually looking at it, there's going to be less area under that curve, right? Let's figure it out. The probability that Z is greater than 7 minus 6, 1.5 divided by the square root of 9. The probability that Z is greater than 1.5 divided by 3 is 0.5. 1 divided, I think this comes out, I just did that in my head. I think it's right. The probability Z is greater than 2.0 if you figure out that mess. Right, because the numerator is 1, this is 3, 1.5 divided by 3 is 0.5, 1 divided by 0.5 is 2.0. So once again, we have to do a Z lookup. We look up 2.0. We get 0.9772. It's greater than, so it's 1 minus 0.9772, or 0.0228. There's only a 2% chance of that. Letter C says, hey, what if we, same deal, but what if we sample 100? What's the probability that average of those 100 come out to be greater than 7? So probability that Z is greater than 7 minus 6, still that's the same. 1.5 divided by the square root of 100. That gives me the probability Z is greater than 6.67. 6.667. I don't really have to look that up because I know my Z table goes 3.89 positive, 3.89 negative. So what is the probability Z is greater than 6.667? Virtually 0. So I'll scan these in, this work I'm doing, and you guys can watch, have it along with the video. Questions on that? All right, so this is trying to determine the size of a market in Mycovania, estimating the population proportion. We're going to use this formula to estimate the size. So we have p hat, this is number 3, p hat plus or minus z sub alpha divided by 2 times the square root of p hat, 1 minus p hat, divided by n. All right, give me something I know, something I can pluck out of that formula right now. Over here. What's something I can pluck out and put in my formula? Very good. I sampled 987 of these very happy Mycovania residents. What else do I know? A says 90% confidence. So what does that allow me to get? 1 minus alpha is 90%. That is, very good. That means z sub alpha divided by 2 is 1.645. Remember, I'll give you that table. But, you know, we've been using only 2, so you guys are smart. So we got this, we got this. We need p hat. So someone tell me how I get p hat out of this. What is p hat? Kira? Right. So I asked 987 of these Mycovanias, and 117 said they make more than $100,000. So 117 divided by 987 gives me, let's call it 11.9%. So all I have to do is plug in my information. We have 11.9% plus or minus 1.645 times the square root of 11.9 times 1 minus 11.9 divided by 987. Let's do it. 0.119 times 1 minus 0.119. That's this part divided by 987, which is my sample size. Take the square root of that whole deal. And I get, and multiply that by 1.645. Okay. That is my estimate, 11.9% plus or minus 1.7%. That means my LCL is that minus that, which would give me, looks like 10.2%. My UCL would be 13.6%, I believe. So I'm 90% positive that the percentage of Mecovanians that knock down over 100K a year is somewhere between 10.2% and 113.6%. So what I've basically answered is A, B, and C, right? I'm done with A, B, and C, the LCL and the UCL. But I want to know the number of Mecovanians that make more than 100K. So I know it's somewhere between 10 and 13%, but I want to know the number of Mecovanians. So how do I get the number of Mecovanians? How do I estimate the number of Mecovanians? Kira? 'Not 100,000. 100,000 is what we're looking to, that's how many residents of Mecovania are there? Not 100,000, there's 4 million. So we have to multiply the high and the low by 4 million, right? The total population, whatever it is, just like the California residents, we multiplied by, I don't know, there's 15 million of them or something like that. So 4 million times 10.2% gives us 408K, and 4 million times 0.136 gives me 544K. So we're estimating, this is part D, yes, and there's no E. E was blank for some reason. So we're estimating somewhere around 408 and 544,000 Mecovanians make more than 100K. That's number 3. Questions on number 3? All right, let's look at number 4. CEO Meco tells you that the market share for his Meco widget in the widget market is 70%. You take a sample of 200 people that use widgets. What is the probability that less than 135 use Meco widgets in the sample you take? So we are doing the sampling distribution of a proportion, which is going to utilize the formula Z is equal to P hat minus P divided by the square root of P times 1 minus P divided by N. Now, in this equation, Dr. Meco or CEO Meco tells you that 70% like his widget or use his widget. So that's P. P is 70%. In part A, we're saying what is the probability that less than 135 use Meco widgets? So 135 out of 200 gives me 67.5%. We're trying to figure out what's the probability that P hat is less than 67.5%. When the population proportion is 70 and I sample 200. Remember, I sampled 200. So we're saying the probability that Z is less than 0.675 minus P, which is 70%, divided by, oh, you guys can see, divided by the square root of P times 1 minus P divided by N, which is 200. Probability that Z is less than negative 0.025, that's the numerator, denominator, we have some work. 70% times 30%, that's 1 minus 70%, divided by 200, that's my sample size, square root. I get the probability that z is less than negative 0.77. That requires another z lookup. It's less than, so all I have to do is look it up. Negative 0.77 gives me 2206. Part B, same logic, but it's a little different. It says, was it probably less than 100 used Miko widgets? So we're not talking about 67.5%. 100 out of 200 is 50%. We're saying, what's the probability that p hat is less than 50%? Because 100 out of 200. Same logic, though. Probability z is less than, let's see, 50%. Minus 70%, 70% times 1 minus 70% divided by 200. The numerator is negative 0.20 this time. And do you notice anything about the denominator? It doesn't change, right? The formula down there is the same, so I'm just going to not do the math and just trust myself in the first step. And I get, let's see, 20% divided by 0.0324. That gives me the probability that z is less than negative 6.17. What's the probability z is less than negative 6.17? Goes from here to here, negative 3.89, positive 3.89. What's the probability it's less than negative 3.89? Virtually zero. Now C says, all right, suppose we do take a sample of 200 people and 99 say that they use Miko widgets. So less than 50% say they use Miko widgets. What does that make you think based on what we just learned in part B? So think about what I did in part B. I said, if the true population proportion is 70%, if I take a sample of 200, that sample proportion should never be less than 50%. I took a sample of 200, it came out to be less than 50%. Shouldn't happen problematically or probabilistically, but it happened, so what does that make me think? Very good. The original claim is wrong. The original claim is inflated, perhaps, or wrong, or over gratuitously. Dr. Miko is saying he owns more market share than he actually does. Okay. So we only have 10 minutes left. And I think that gets you ready for Tuesday, I hope. But I also wanted to make you aware that for Thursday, the 2nd, Groundhog Day, on Blackboard, under take-home assignments. Thank you, Brooklyn. On Thursday, under take-home assignments, we have our first Excel assignment, 2017. Okay. It has 5 problems. This is you're going to bring this in. You're going to print it. Do not submit through Blackboard. Please print. Bring to class. There are 5 problems. You're going to estimate the mean using Excel. You're going to estimate the proportion. This first one is the average amount of cells, so this is the mean, 99% confident. This one is average amount of shipping costs, 95% confident. This is a proportion because we're doing market share. Market share is proportion. And these two are also proportion. Did we do this one today? That's a giveaway, right? You did 14 for homework. I should update this.
I think it's good. It's okay.
And you know what? I'm a little leery. I was going to give you, I have a sample Excel quiz out there. I was going to give you Thursday, but we only have like 6 minutes. I don't think I'm going to have time to go through that. So maybe I'll just give that to you the following Tuesday, just to make sure that we're good. I don't want to. So that's going to be my plan. But this is still due Thursday. Okay, so you have some. I don't want you to go a day without homework. So you can do that between after the exam Tuesday before Thursday. You can do that. Okay? Have a great day. I will see you next week. And remember, I'm going to spread you out. No offense, but no trust anymore.